Hello guys, we are going to show you a very quick, probably 4 or 5 minute video on how to do an ANOVA test. That stands for Analysis of Variance. And we're going to test that using StatCrunch and show you how to do that particular problem. So in this particular problem, they're looking at the amount of nicotine per cigarette in different cigarettes. King size, 100 millimeter menthol, and 100 millimeter non-menthol. So basically, your HO says that all three are the same, like one equals the second equals the third. Your H1 or your opposite says at least one of the three is different. You're not saying if it's more or less, you're just saying it's different. It does not match. So it says find the F statistic. That's what we're going to show you really quickly. And we're going to also find the p-value for your statistic. And then you'll have to understand how to make your conclusions based on your p-values and then your interpretation of the data. So here's our chart. Here's all our information. King size, brand 1 through 10, menthol, so on and so forth. And of course, over here, here's our little StatCrunch symbol. So I pop it up in StatCrunch. I'm going to widen this a little bit so I can see some more stuff. Here's how we run an ANOVA test. Stat, ANOVA, one way. So now I have to say, what am I comparing? I want to compare king size with menthol and non-menthol. I can come down the rest of this. I really don't have anything I need to do here. All I need to do is select my three values that I want to compare for an ANOVA. Remember, with an ANOVA test, you need at least 3 different columns to compare them. I very quickly hit compute. Up pops my dialog box with all of my information. So let's just give you what you know. King size, 10. Average of that, standard deviation of that. So it gives you your summary statistics of your column very quickly right there. Now the ANOVA table, if you remember from your reading, we have the sum of squares, the mean of squares, the degrees of freedom. It has all this calculations that it did, and those are all in-between calculations that a statistician would use much more in depth. But we're not looking to necessarily be that type of person in a statistician. We're looking for the interpretation of the results that I get. So you can see my F stat right there is 3.9168467. Well, that's the F stat that it's looking for over here. The F statistic is 3.9168. That was the rounded version of this. My p-value comes out to be 0.0321. There's my p-value right there. Now, in this course, we're just worried about trying to turn around and make determinations on statistics. We're not actually doing the computations. So right here, it says use a significance level of 5%. Well, our p-value is 3%. So since our 3% is less than our 5%, we are going to have to reject the null because basically the chances of what we had is only a 3% chance, 5% chance significance level. So we're going to need to reject the HO as there is sufficient evidence to warrant the rejection of the claim that the 3 categories of cigarettes yield the same mean amount of nicotine. Now, that does ask you to extend a little further. Do the filters appear to be making a difference? Given, I have the largest mean, it appears that the filters do make a difference, although this conclusion is not justified by the results from analysis of variance. That's the important part. We are not turning around and saying one is higher than the other. We are just simply, we're not saying which one's higher. We're just saying one is different than the other. So what conclusion can you make? Or it says, do the filters appear to make a difference? When we go back to our data, we can see that king size and menthol, and then we have filtered, and filtered does have the lowest mean. So given that the king size cigarettes have the largest mean, it appears that the filters do make a difference because they have the smallest mean. Now, that does not mean that's 100% guaranteed true fact. It just is saying that appears to be the case. So remember, with your ANOVA test, you are not turning around and saying which is higher and which is lower, but you can make some interpretations about it, but you can't say it as a concrete fact. Again, how do you do this? Stat, ANOVA, one way. I pick the columns I want to look at. I hit compute, gives me my numbers. I need my F statistic. I need my p-value, and those are the numbers that I'm going to be dealing with. So that short video hopefully shows you how to handle your ANOVA problems. Now, mind you, there are different problems of this type. Those are for you to figure out how to apply the answers in the ANOVA, but at least this short video shows you how to get to that in StatCrunch and how to run the test.